So someone sent me this model and said that they had run a thermal analysis and it worked, and then it just stopped working for no reason. Let's troubleshoot it. First thing I want to do, I know that I was looking at this briefly, and these this is the layers that have the zones on it. I want to just make it to where I can see the outline. Find that much clearer. First thing to say is this is a really well organized model. I really appreciate that. It's basically mimicking what I have shown in class. Makes it so much easier to troubleshoot. I can turn things on and off very easily and isolate different simulations because they're on different layers. Very good. And it's a it's a well modeled simulation model. I can tell that the zones seem to be working. They're white, right? And the windows are blue without a red border, which means that they're coplanar with the exterior surfaces of the zone. I do see these yellow adiabatic surfaces here, which I'm assuming, yeah, there are here. Let's just start with that. No, actually, what I want to do first, though, so I want to run a simulation straight out of the box. They're saying this was set up as they ran it, and let's see what happens. So here's our output. We did get a successful run, and I'm assuming that when this person said that it worked before, um, that this is what they did. They got the output. Um, it's immediately suspect to me because we have a baseline for whatever building type they chose, and our uh, performance is well below that already. I'm sure this is not an optimized model. And so then if I look at my energy use intensity chart, it's all lighting and equipment. There's no heating and cooling loads. That's not going to happen in New York City. I mean, you could theoretically design a building that had no heating and cooling loads in this climate, but this building's not going to be it. Um, and it would have more going on than this if we look at our energy flows chart, then we can see here the same thing. We have our window, I mean our envelope, our windows, our lighting load, our people heat load, um, air infiltration, but no heating and cooling. So there's obviously a problem there. And the problem is, if I go to my mechanical systems tab, that there are no, this mechanical system is not applied to any zones. Um, I've seen this happen where, like for example, however you created this, they created this model. If they used a template, or basically there's going to be a default mechanical system applied, and you can run it once, and that will be there. And then the next time you open up the model, it will often the simulation just takes it, just turns them off. I'm not sure why it does that. It doesn't always happen, but you just need to check and make sure that you have a mechanical system applied to your zones. It's easy to do. I'm going to select, and I'm going to assign. It seems like a lot of zones, right? So we'll have to check that out. But I'm going to apply that mechanical system to all my zones, and now I'm going to run the simulation again. And here are our results. Now we have a huge heating and cooling load, like 51 million kilobTUs per month in January. That's insane. Um, and we have a cooling load also. I'm going to go ahead and save this one, test 3. Um, so what's going on here? I don't know, but let's check it out. If I come back to my zones, oh, actually, let's look up here. Whenever you run a simulation, you'll get information about it in the command line above the command line. And I can see here that, first of all, I've got a bunch of children's libraries. That doesn't really make any sense. And they're all smaller than 1 meter squared. And it's saying to check our dimensions. So let's check our dimensions. About 20 feet for that height. That looks reasonable. So what's up with that tiny um, children's library thing, and why there's so many of them? Uh, by the way, there's other information about your runs in a run log. It's more technical, but it's interesting to look at, and you can learn things about the problems you're having with your thermal simulations. There's always going to be information because there's always little things that are need to be notated or are not exactly correct, but usually you don't break the simulation, and it's good enough for our purposes. Um, okay, so what's going on here? If we go back to look at our zones, why do we have all these different children zones? And if I click on them, I see that they're individual surfaces, which is weird. Why would that be true? And then same thing with the cafe. I've got a bunch of cafes. Um, if I come back and look at my really well laid out model so that I can quickly iterate, I see there's this ADB layer, which I'm going to turn off. Or actually, I'll turn it back on, and I will select the objects. Yeah, that looks like a bunch of individual surfaces. Maybe at some point, these are actually the rest of the adiabatic surfaces, probably when you did that assignment 9, I'm guessing. In any case, we don't want them in our run, and when I turn them off, it gets rid of all those crazy zones in our thermal analysis simulation. Uh, and so then I can start clicking through here and um, checking it. There's my children's library. That's great. Everything seems to be good. So if I get up here and there's still another children's library, it's just an individual surface here. So for some reason we didn't catch it. It's on a different layer over here. If I select my children's library, it looks like it's redundant. So I think I can, in other words, that surface is in the children's library also. So I'm just going to delete it and see what happens. And yeah, it seems like it's still there. I mean, it seems like it's part of my children's library zone. It didn't break anything, so I think that's going to be good. It's going to work. Um, so let's make sure now we have only 9 zones, which makes sense. And our mechanical system is applied to all of them. Let's delete these again. I thought I deleted them, or did I talk about them? We don't have any adiabatic surfaces in this model, right? We have ground, we have surfaces that are exposed to the outside, and we have partitions. Remember that the partitions are automatically created by the simulation, because if you have 2 zones next to each other, it says, oh wait, well that's a partition between those 2 zones, and it just automatically creates it. So we don't need these, so I'm going to delete them. Yeah, now this looks pretty good. Let's run it and see what happens. So, interesting. It didn't fix it. Did change it slightly. I know we don't want those surfaces, so that was a good thing to do anyway. But because if those are adiabatic surfaces, well, actually they were zones, so it's just going to confuse the model. But there's another problem then. Let's find it. Okay, so I feel like that the model is set up well. We're not getting any errors from there. Um, Let me look at the actual, the settings here. And if I go and I'm going to select everything and edit. So I'll just start with the space use. This is not, by the way, I remember that there is for both space use and, let's see, get the other one. For both space use and construction, I provided templates that I wanted you to start with. And so for space use, sorry, this is taking me too long. Right, so for, yeah, I was noticing that you didn't have the same settings I have for lighting power density, etc. So just make sure you're starting with those as a baseline if you're working in the class. But those are at least tenable. These make some sense. This is higher than what we had set, and this is going to cause us to have a higher heating or cooling load, because this is we're bringing in fresh air, and so that's going to cause us to lose just to use energy. But okay, Let's check the other template, which is the 90.1. If I'm looking through here, so you're using the default construction, which was the baseline. So I think you're trying to do that here. And then I see, oh yeah, the airflow. Let me open that one up again. You see that the baseline setting for this CFM per square foot is 0.2, and you have it at 40. So that's a crazy amount, right? And we're saying that's air leakage through the exterior surface area of the building. So let's change that to 0.2 and run it. And here are our results, and we see now we have something much more reasonable. We do have heating cooling loads, and we have clear loads from the different parts of the building. Like, so for example, we obviously would really want to work on the envelope here, and since the default is all concrete that I saw you set it to, which is what I wanted you to, then that's going to be easy to improve. So it turned out that there were a lot of problems that I think um, all were breaking the model. Um, and we need to go through systematically like that to find them. But in the end, I think the most important one was just a simple setting change or a mistaken setting, which is, I know that typically you guys are not going to understand those airflow rates that well. I've talked about them, but that goes in one ear and out the other because it's a new thing. Um, so you just want to be really careful that you're applying the template, the baselines as I've defined them. And then as you're trying to iterate to optimize, you can ask me questions about, well, or you'll just try it. Try a different setting and see what it does. And then you might say, what's a good setting for this that's an optimized? And we could talk about it. All right, so the point is that this model is fixed. And it was easy to do because it was well organized. And now we can optimize this moving forward.